and we have a long evening today. I would just like to state that we would like to split the webinar into two parts. The first part would be understanding diversity in a VRF system. So once I finish the presentation, probably we can answer the questions related to understanding the diversity in a VRF system, and then go to the next presentation that is on good installation practices in VRF systems, and then address the question related to that, because if we are going to go on for 2 hours for a long time and the presentation, in case I have to make any reference, it becomes difficult for me to later jumble between the two presentations. So it is advisable that we split it into two parts. The first part, questions will be answered after the first part of the meeting, and the second part of the questions will be answered in the second part of the presentation. Okay, so this is the disclaimer which we generally present in all the platforms. The information provided within this webinar is for general purpose only. While we try to keep the information up to date and correct, there are no representations or warranties expressed or implied about the completeness, accuracy, reliability, suitability, or availability with respect to the information, products, services, or related graphics contained in the webinar for any purpose. Any use of this information is at your own risk. We do not guarantee or declare that the information on the webinar is accurate and correct. We are not responsible, nor can they be held liable for any errors or HSS in the content of the disclaimer of the webinar. The speaker's views expressed in the presentation made at webinar or other webinars are those of the speaker and not necessarily that of ISHRE. Presentations or the presence does not constitute an endorsement of the vendor or the speaker's views, products, or services. Now, I have added an other important thing here, that is, please refer manufacturers' operation, service, installation manuals of respective brands for specific details. So whatever presentation I'm going to make is going to be generic and it's not going to be brand specific. So any brand of air conditioning system of a VRF which you are doing, it is advisable for you to refer those owners' manual for specific instructions. So with this, I would like to move forward. So I will start with a basic slide, like what is ton of refrigeration. We all talk in terms of say 1.5 tons, 2 tons, 50 tons, 25 tons, 30 tons, etc., etc. So what is this ton of refrigeration? Ton of refrigeration is basically it is the rate of removal of heat. That means, for example, let us say, for example, we have to air condition a room. In that room, first we need to ascertain what is the amount of heat that is available in that room, and then how much time does it take to remove that heat from that space. That is known as the rate of removal of heat. So a ton of refrigeration is defined as the rate of removal of heat. So what does it mean when we say 1 ton? So it means that 1 ton is equal to 12,000 BTU of heat per hour, 3,000 kilocalories per hour, 3.5 kilowatts, or 1.25 HP. So when we say it is 12,000 BTU of heat, that means if you have a room of an enclosed space, and there are 12,000 BTU of heat in that room, and if you have to remove that heat in 1 hour, then you will need a 1 ton of refrigeration air conditioning system. Or in other words, you have 3,000 kilocalories. That if you have to remove the 3,000 kilocalories of heat in 1 hour, you will need a 1 ton air conditioning system. That is what it means. Why I'm specifically talking about kilowatts and HP is generally the VRF systems are discussed in terms of HP. That is, let us say, for example, I have a 30 HP system, I need a 40 HP system or a 50 HP system. Generally, the direct calculation is 1 ton is equal to 0.8 HP. 0.8 HP is equal to 1 ton, or 1.25 HP is equal to 1 ton. So you multiply it by 0.8, you will get the required capacity. So that is the general calculation that we follow. Right. So what does an air conditioning system comprise of? The air conditioning system comprises of the highest power consuming component in the air conditioning system, that is known as the compressor. Then you have the condenser, then you have the evaporator, then you have the expansion valve, then you have a bypass system if required. So what is the difference between a conventional air conditioning system? And I would like to first talk about the inverter technology, because the compressors that are used in all the VRF systems are inverter based compressors. So first let us discuss about what is the difference between a conventional air conditioning system and an inverter air conditioning system or a compressor used in a VRF system. Generally what happens in a conventional air conditioning system is that you have the set temperature. Let us say, for example, you switch on the air conditioning system when the ambient temperature is 35 degrees centigrade, and you switch on the air conditioning system. It takes about 20-25 minutes for you to cool. So once the temperature is cooled in that place, in the conditioned space, the compressor goes off. Once the compressor goes off, then the temperature starts increasing. Now, if you look at it in a graphical position, see, here is your ambient temperature. The temperature, the air conditioner starts bringing down the temperature. The graph is coming down, and here at this condition, the compressor is off. That means the compressor either runs at 2800 RPM or 0 RPM. I think somebody has unmuted the mic. Can you please mute the mic? Okay, thank you. So when it is running at either 2800 RPM or it is running at 0 RPM. In this condition, it is running at 0 RPM. Now, once this heat is removed, because the heat is constant in a room, the temperature tends to increase. Once the temperature tends to increase till such time that there is something called as a delta T, which is generally about 3 degrees. It also depends on thermostat to thermostat based on the setting what you have. So this delta T is generally about 3 degrees. And when the temperature reaches to say 27, if your set temperature is 24, when it reaches to 27, the compressor starts running again. So this cycle keeps repeating on and off. So this is what happens in a conventional system. The room temperature increases rapidly when the compressor turns off, which results in an unstable room temperature. Let us typically look at somebody who has a fixed speed air conditioning system in his room. Generally in peak summer, what they do is at 10 o'clock in the night, or maybe at 9:30, whatever time they sleep, they switch on the air conditioning system by about 9:39, set the temperature to 23 or 24 or whatever comfortable temperature to them, and they go to sleep. Midnight, maybe around 2 o'clock or 3 o'clock, they start feeling cold because the ambient temperature would have dropped and 22 or 23 degrees would be too cold to them. So what they do is they get up during the middle of the night, they switch off the air conditioning system, or they switch off the compressor. The compressor they will not be able to switch off because you will be in a sleeping mood. So you just switch off the air conditioning system, and maybe you may switch on the fan. But then what happens is, because of the heat inside the room, the temperature starts increasing again, and by about say 4:30, 5 o'clock in the morning, or even 5:30 in the morning, you start feeling hot. So then what happens is, again you get up and switch on the air conditioning system. Now this cycle keeps happening constantly. That means it is this on-off cycle keeps happening constantly. Now let us understand what happens in an inverter air conditioning system. Now when you have an inverter air conditioning system, once you set the temperature to 23 degrees centigrade, the compressor starts from 0 RPM, slowly goes to the full speed till such time the desired temperature is achieved. The compressor runs at full speed, and once the temperature has reached, let us say, for example, you set the temperature to 23 degrees centigrade. Once the temperature has reached 23 degrees centigrade, here the compressor doesn't go off. Now the RPM of the compressor, that means the speed of the compressor, is reduced to maintain a temperature of 23 plus or minus 1 degree centigrade. So that means what happens is, here this on-off doesn't happen here. Now this maintains a constant temperature so that you do not feel uncomfortable. There is no increase or decrease in temperature during the working of the air conditioning system. So this cycle keeps, this type of system maintains a constant temperature, thereby increasing the efficiency of the system, enhancing the comfort, and also at the same time it maintains a constant temperature. So now what happens, how it maintains a constant temperature is very similar to what happens in a VFD. Now I would like to give a common change. Now range of room temperature changes is small because if the set temperature is reached, the compressor will not shut off to control the temperature, but will maintain temperature by decreasing or increasing the speed of the compressor. So this is what happens in an inverter based compressor. So you maintain a constant temperature. Now, if I were to give a common comparison between the inverter and a conventional air conditioning system, now a conventional air conditioning system is like driving your vehicle in city. It is like driving a car in city. You start the car, you run the car, in between somebody comes, you stop, you brake, you change gear, again accelerate. This keeps happening and when you are driving in the city. Now this is a typical driving in an highway, national highway, where nobody comes in between. You maintain a constant speed which enhances the mileage. So this is the difference between an inverter speed and a fixed speed compressor. The common man's comparison is by like driving a vehicle in your city and like driving your vehicle on a highway. So generally in highway you get a better mileage. Similarly in an inverter air conditioning system, you tend to get better economy, or it's more economical. You get enhanced comfort also. Now, so in a nutshell, a fixed speed compressor works at a constant speed, which results in longer time to achieve the set temperature, on-off cycle to maintain the set temperature, resulting in over undercooling. The room or the temperature variation could be plus or minus 2 degrees or the set temperature. So there's a huge waste of energy. Now, in an inverter system, it continuously changes the compressor revolution based on the load and less time to achieve the temperature by increasing or decreasing the compressor RPM, maintains a set temperature of 0.5 degrees centigrade or 1 degree centigrade by lowering the compressor RPM. No frequent on-off of the compressor. Now, I want you to understand this very, very clearly, since this plays an important role when we are talking about diversity in a VRF system. Now, what is a VRF or a VRV type of air conditioning system? VRF is termed as variable refrigerant flow. VRV is known as variable refrigerant volume. However, both are same. There is no difference between VRV and VRF. Some brands call it as VRF, some brands call it as VRV. So both are same. There is no difference in the type. So what is a VRF system? A system that provides climate control and zoning of the comfort, effective energy consumption by means of optimized inverter-driven scroll compressor or a twin rotary compressor, and temperature controls producing high responsive cooling or heating. You can have the option of both heating and cooling in a VRF system. So what is a VRF system? It is a central air conditioning system in which refrigerant flow is varied depending upon the cooling and heating requirement, or it is also known as heat load of the system or the place. It is a system that provides climate control and zoning comfort. This variable refrigerant flow effect is achieved by inverter controlled rotary or scroll compressor, electronically controlled expansion valve, and to assess this the communication between these two is provided by the microprocessor based controls. Please note the microprocessor based controls also play a very, very important role here, because you need to have a constant communication between the compressor and the expansion valve by which the variable refrigerant flow is taking place. Right. So what is the VRF system? It's a direct expansion type of air conditioning system. Facilitates multiple types of indoor units of various types and capacities. So there is no restriction. You can have a cassette, or you can have a high wall, or you can have a ductable unit, you can have a one-way cassette in combination to the various condensing units. Then connected to one or more outdoor units, you can connect more outdoor units. However, the number of outdoor units has limitation based on the manufacturer to manufacturer. Then permits usage of diversity in indoor unit selection. Now, this is what we would going to be talking about today in this presentation to understand what is this diversity, how we can use this diversity, where we can use this diversity, which application is beneficial, and what is probably, again, I'm repeating, probably the right way of selecting the diversity. And whenever I talk about diversity or whenever we talk about selection in diversity, we all talk about based on the practice what we have got, our experience in the field. We would have experimented with various types of diversities, and we feel that at this particular diversity, you get an optimum condition which is acceptable to this particular type of application. That is how we discuss on this diversity today to understand the selection of a VRF equipment. So common types of compressors used in VRF system, you have an inverter scroll compressor, or you have a DC twin rotary compressor based on the brands. And so a typical VRF air conditioning system will have a part load operation, a user friendly. It has to be user friendly. It should be individually controlled. What I mean to say is, let us say, for example, you have a conference room which is not working and you switch off the conference room, or you have a manager cabin which is working for 8 hours or 10 hours a day, and at the temperature there also could vary. You have a managing director who would like to have 22 degrees temperature, whereas the manager would require to have 19 degrees temperature. So you have the option of having 19 degrees in the manager's cabin. You have the option of 22 degrees in the MD's cabin. So this is an advantage with the VRF system, where it can be individually, the temperature can be individually controlled, and the type of indoor unit can also be varied based on the requirement or your system design or whatever it is. You have a wide range of IDUs, and again diversity, which we will be talking about more today, and you will hear more and more about diversity today. So what are the key benefits of a VRF system? Now, how does it consume less power? I would like to take a minute here. How does it consume less power? How does it provide high power when required? How does it provide enhanced comfort? And how does it requires a very low starting current? Of course, it doesn't require any explanation. Let me just explain to you, how does it consume less power? An inverter system, how does it consume less power? I will just give you a small example. Now, let us assume that you have a 1-ton inverter based system, and your 1-ton system consumes a power of 6 amps. Let us say that it consumes a power of 6 amps. What happens here is, if you take P is equal to VI, that is power is equal to voltage into current into power factor. For a single phase system, your power factor is 1. So that means we have left out the power factor. It is P is equal to voltage, V is the voltage, and I is the current. Now let us take an example for this. Now for a fixed speed system, let us understand that you have a 1-ton air conditioning system which is consuming a power of 6 amps. That means effectively it will be 220 into 6, which is about 2120 watts. That means your compressor is drawing a power of 2120 watts. That it is either consuming 2120 watts or 0. Let us assume if you are doing on an 8 hours operation, 60% of the time or 80% of the time is the compressor is running. That means it would consume a power of, for 8 hours of operation. Let me take about 8 hours of operation here. 8 hours will consume about approximately 1,700 watts or 1.7 kilowatts. That means if your air conditioner runs for 1 hour, this consumes a power of, let us say, 1.7 kilowatts into 8 hours will give you the power consumption. Now let us come to the inverter type of air conditioning system. Now here what happens when you're using an inverter is, if you have a 1-ton system which is drawing 6 amps current here, now what happens is, once the compressor speed is reduced, once the temperature is achieved to 23 degrees centigrade, now the 6 amps will probably reduce to say 3 amps or 4 amps for 4 amps. So what happens here in this case is, if this is going to be 6 amps, that is 6 amps becomes 3 amps or 4 amps. I will take 4 amps, which is on the higher side. So it is voltage into current. That means voltage is equal to 220. 220 into 4 will 220 into 4 will give us 880. So that means here it consumes 880 watts per hour, whereas here it consumes 1700 watts per hour. Now this is how the power saving happens between an inverter based system and a fixed speed system. This is just a generic, the best way to practically measure it is to put an ammeter to the air conditioning system what you have, measure an inverter based system and measure a fixed speed system when the compressor is running. This is how you will try to get this formula. You can note down this formula, which is a very simple formula to get your power consumption, that is P is equal to VI. Right. So we have discussed there are the various types of VRF system. Now you have a partial inverter system, you have a single inverter system, then you have an all inverter system. So now what is the difference between each type of inverter system technology? Let us understand. Now if you have, let us say for example, these are known as multiple compressor systems in a partial inverter system. What happens is, if let us say for example, if you have a 10 HP system here which has got 2 compressors. Now in this 10 HP system, if you are using a partial inverter, what happens here is about 20 to 30%. Again, based on the manufacturer to manufacturer, this could be vary between say 20% to 30% or 15% to 17% or 18% of 10 HP. That means you will have about, let me take 20%, you will have about 2 HP as the inverter compressor, and the balance 8 HP will be a fixed speed compressor. So this is what happens in a partial inverter. That means you have a fixed speed compressor which is of 8 HP and you have an inverter compressor of 2 HP. Now the problem here is, when you have, let us say example, a load of 4 HP. When you have a load of 4 HP, it is the 8 HP compressor which runs and not the 2 HP compressor. The 8 HP compressor runs at full speed and the inverter compressor comes into picture only during the starting when it comes on partial load. So this is how a partial inverter works. And then you have something called as an all inverter machine, where let us say with the similar example of 10 HP, you will have 2 5 HP, 5 HP compressors. And if you are, let us say, running on a partial load of 3 tons, now both the compressors will run at 1.5 ton, 1.5 tons, so that the wear and tear is uniform and there is no spike in higher temperature or lower temperature, etc. So it maintains a constant speed, and it is like sharing work. If you have to, let us say, carry a 10 kg bag, here one person is carrying a 10 kg bag, here 2 people are carrying 10 kg bag, whereas here on one side you have a small boy carrying a 10 kg bag, on the other side you are carrying the rest of the load. So this is the difference in a common man's language. And you also have single inverter system. That means, let us say for example, you have VRF systems, which if you have a 10 HP system, you will have only one compressor which will run on 10 HP, but it will all be 100% inverter. That means if you want 3 tons load, this will run only at 1/3 the speed that it runs at full speed. So these are the basically various types of inverter systems what you have in VRF. Basically, it is namely a partial inverter, an all inverter, and a single inverter compressor type of inverter compressors. I hope all of you are understanding and I'm not fast. I'm audible and I'm clear. Then, so what happens, like I explained, in an all inverter compressor, the load is distributed equally. So because the load is distributed equally, you get a higher coefficient of performance. That means the compressor works more efficiently. Now, in a partial inverter, what happens here is Either when you have 50% load, the fixed speed compressor or the inverter compressor is running at full speed and the fixed speed is off. So that means this compressor will always keep running at full speed, or vice versa. When you have 100% load, both the compressors run together. So this is the basic difference between an all inverter type of a system and partial inverter system. Now, this is another diagrammatic representation which has been given based on the load pattern here. Now, if you look at the load, we have divided the load into 1, 2, 3, 4, 5, 6, 7, 8 parts. That means, let us say, for example, to make it easier, I will consider only 8 tons here because we have 8 parts. Now, if you have a 1 ton load here, that means your inverter will run on low RPM. Now, if you have, let us say, for example, 4 tons here, your inverter is running on low RPM, whereas your fixed speed is running on full RPM. Now, coming to this scenario where you have all inverters, where if you have multiple compressors, all the 3 compressors or 2 compressors are sharing equal speed. Now, if you, let us say, for example, come to 7 tons here, now you have an inverter compressor running here on partial speed and the fixed speed compressor is running on full speed. Now, when you come to an all inverter compressor system, all these 3, like for example, all these 7 tons is shared by 2 or 3 compressors in equal ratio. Right. So how does a VRF system operate? How does it control? So each indoor unit controls its capacity via a proportional integral derivative. So we use something called as a PID. We use something called as a PID. PID is nothing but proportional integral derivative to control each of these indoor units through an electronic expansion valve. So the communication system what we have is proportional and integral derivative. Condensing units adjust to the inverter compressor to provide the required capacity. So this is a diagrammatic representation where you have a refrigerant liquid line, where you have a refrigerant suction line, and then you have a remote sensor, then you have temperature control sensor. Now, please note you have 2 sensors here. One is the air sensor and the other one is the temperature sensor on your coil. So you need to communicate between both of them, that is between the air temperature sensor of the air and the temperature sensor on the coil. So these 2 needs to communicate between them in order to give you an enhanced comfort, and how it happens is because of opening and closing of the expansion valve. Okay. So now this electronic expansion valve, now if we would always have, we would have got used to a thermostatic expansion valve, which is either always open or always closed, and we call that as a valve open in equilibrium. Whereas now an electronic expansion valve is never in equilibrium, because I would also like to explain at this point of time what an expansion valve does. Now, an expansion valve is also known, it has got 2 names. It is also known as metering device. Now, how does it meter? What does it meter? Now, depending on the load. Now, when I say load is depending on the heat. In air conditioning language, when we talk about load means heat. Now, depending on the heat inside the room, the air conditioning system has to remove that heat. So, depending on the load inside the evaporator, or the expansion valve allows the flow of liquid refrigerant into the evaporator to cool that quantity of air or to remove that amount of heat. So based on the load on the evaporator, now this electronic expansion valve starts moving up and down. That means it controls the flow of refrigerant. It throttles the flow of refrigerant by opening and closing of this expansion valve. That means, to be more precise, now you have about more than 2,000 steps in this small expansion valve. Look at the precision at which it should work. And then you also have a PID signal sensor here, which enables the opening and closing of this valve. Hope this gives you a clear explanation on how this expansion valve works. And because of this precise communication what you have here, this allows the movement and opening and closing of this 2000 step controlled electronic expansion valve. And this is how you get the precise control of refrigerant into your evaporator. So this is how it achieves energy efficiency also. Then, so what is an inverter type system? The inverter controls and adjusts the supply frequency. Thus, the rotational speed of the compressor is controlled, very similar to what we have in the VFD, variable frequency drive, which we use for our AHUs or fans to vary the speed. It is similar to that. So the same drive system is also used here inside, and the compressor will have an inbuilt inverter box which will vary the speed of the compressor. Right. So now again coming back, this slide is repeated because now we are moving on to the real topic what a VRF is about. That is, we will now discuss more on diversity. So what is this diversity? Where we are going to use this diversity? How we are going to use this diversity? Because all this time we were trying to understand what a variable refrigerant flow system was, and now once we have understood what a variable flow refrigerant system is, we move on to the diversity. So what is this diversity? Let us understand. In a common man's language, if you look at Oxford Dictionary, what is diversity and when, where it is used, what type of application it can be used, and what are the benefits, before we understand, I was just wondering, whenever I make any presentation, I try to pick the most difficult word to understand it in a more simpler way. So when I started to learn about what this diversity is about, first I opened an Oxford Dictionary and referred what is diversity. So the simple explanation what Oxford Dictionary gives for diversity is a variety, an assortment, it's a mixture, then it's a range, it's a medley. Medley we all know, like singing a song continuously, different songs are sung together. Multiplicity, heterogeneity, diversification. Now let me come to this point. This is a very important point for us since we are talking about diversity. That means the difference in capacity. Now, in a VRF system, when we are talking about diversity, I would like to take this difference as the important part here, and we are going to discuss only on this difference. What is this difference? When is this difference? Where this difference can be used? And the second one is the unlikeliness, the dissimilarity, all this. So in general is known as diversity. So let us try to understand in detail what is this diversity in a VRF system and how we can use this diversity in a VRF system. Right. ASHRAE defines diversity as the probability. That means perhaps, yes, if I can. That means probability that an integral kind will arrive at the peak load of the building. So peak load, what we are talking is, let us say, when if we say about 10 tons, that means we have 1,20,000 BTU of heat to be removed. That is known as the peak load. That means always we have 1,20,000 BTU of heat to be removed. So, or at the time where there is 1,20,000 BTU of heat is there, that time is known as peak building load. So, ASHRAE has noticed that in an office building, there are a lot of diversity. That means your peak load is not constant. There is variation in the load, and that variation in load ranges from 70 to 85% and always between 42 to 89%. Now let us try to understand this more in detail. When it can be used is diversity can be considered when there is a difference in variation in cooling load or heating load. Then, so what is cooling load or heating load? Heating load or cooling load is nothing but heat load or the quantity of heat to be removed from an enclosed space is known as the heating load or the cooling load. It includes both sensible heat and latent heat. It is also known as cooling load. and it is generally expressed in British thermal unit per hour. So this is what we have been talking about now. Load is heating load or cooling load. That means the amount of heat to be removed. It has a combination of both sensible heat and latent heat. Then, so what are the various types of heating loads and cooling loads? There's a room internal load. That means everything that is there in the room should be considered. The people inside the room, then lighting inside the room, equipment. Let us say you may have a PC or you may have lab equipment or whatever it is. Then infiltration load. Infiltration load is nothing but coming through your door gaps or window gaps, etc., are known as the infiltration load. Then the system gain load. Let us say, for example, you have a fan inside, or you have a television inside, you have a UPS inside. Those are the heat coming out of those are known as your system gain, or your own indoor unit fan, which is running, generates some amount of heat. So that is known as the system heat gain. Then miscellaneous sources and your outdoor load. Outdoor load is nothing but your fresh air load or outside air load. Then your fresh air load, which I've already explained. So this constitutes something known as a heat load or a cooling load, where you have external load, internal load, all types of loads put together, and this is how we need to estimate what is the total heat inside the room. So this is a typical sheet of a heat load or a cooling load estimate. Now, if you look at this generally, now this is for a location in Andhra Pradesh, which we have derived at. So this is generally broad, let us say, the summary of the heat load sheet of hourly air program. So this is from HAP. So this generally gives you a summary of various things. I want you to observe two things here. One is called the refrigeration tonnage. That is known as the total cooling load. That means your coil load. Then the second thing is your quantity of air. Now, at this point of time, I would like to explain what is air conditioning. Now, air conditioning is a process where you control temperature, humidity, cleanliness, odor, and the fourth important point is the movement of air. Now, this quantity of air is very important for us, because what happens here is if the quantity of the air that is there is not sufficient, you are not comfortable inside the room. So the tonnage is the one that is required to remove the heat from inside the space, and the quantity of air is the air required for you to keep comfortable inside the room. So this is we need to balance between the tonnage and the quantity of air. Now, let us say, for example, I will give you a refrigeration system or an outdoor unit which will give you 3.8 tons, and I will give you an indoor unit system which will give you 1900 CFM of air. I don't see any reason why you should not be accepting it, because I am trying to marry my 3.8 TR condensing unit with an indoor unit which will give me the required quantity of air, which meets both my ends. Otherwise, what happens here? Let us understand. Now, if you put, let us say, a 4-ton air conditioning system, and assuming that you are going to have a cassette type of indoor unit, which generally delivers about 300 CFM of air per TR for cassette. So what happens if you have to achieve this 4-ton? You will get about 1200 CFM of air. So that is what you get. Now but our requirement here is 1900 CFM. Now let me divide 1900 by 300. 1900 by 300 gives me 1900 by 300 gives me about 6.2 3 tons. So 1900 divided by 300 CFM per ton gives me 6.3 tons. Now I am in a catch-22 situation because my load here says 4-ton air conditioning system is required. But if I have to look at the quantity of air, now I will need a minimum 6-ton air conditioning system. So what do I buy now? Do I buy a 4-ton air conditioning system or do I buy a 6-ton system? Now, coming to the most important part, if I were to give you a VRF system, that means the VRF system has got an outdoor unit and an indoor unit. I will give you an outdoor unit of 4 TR and I will give you an indoor unit of 1900 CFM, which can deliver 1900 CFM, and I will give you an outdoor unit which can remove, let us take 4 ton, it can remove about 48,000 BTU of heat. So I will give you an outdoor unit which can remove 48,000 BTU of heat. I will give you an indoor unit which will deliver 1900 CFM of air, which will satisfy both your requirement. Now, this is known as a diversity between indoor unit and outdoor unit. The difference between indoor unit and outdoor unit. Say, for example, what is the capacity of your outdoor unit? Your outdoor unit is 4 tons. Your indoor unit is 7 tons. So this is just an example what I am giving. It does not mean that you want a 70R system, you can use a 4-ton system. No, it is based on the heat load. So we are trying to come upon, agree upon this difference between indoor unit and outdoor unit mutually in achieving the desired condition for us, which would save power, which would give us enhanced comfort, etc. So this is known as the diversity between indoor and outdoor, which I will try to explain in further slides in more detail. I hope this basics is very clear to you. So you get something called as a refrigeration tonnage here, which is your cooling coil load, and then you need a quantity of air to keep you comfortable. That is known as the dehumidified CFM, and it is always important for us when we are talking about comfort air conditioning. The dehumidified CFM or the quantity of air is more important for us than the refrigeration load. However, we need to balance between the outdoor unit capacity and the indoor unit capacity, and that is what generally we try to do optimally in a VRF system. So according to actually the previous 2 slides which you saw, I will go back to that slide for a minute. Before the slide, what you saw here, Ashley says that before we took up the diversity, this is where this figure comes from, that is 70% to 85% and 42% to 89%. Now there I have got that is from this slide is where I have got. Now if you look at this here, 75% of the time you have 42% load and 50% of the time you have 45%. That means 40 plus 40, 87% of the time your load is anywhere between 50 to 75%. That means, to put it in a nutshell, in a 10 hours operation, you have 50% load. That means for 5 hours, your requirement is only 45%, and for 7.5 hours, your requirement is only 42%. That means for 87% of your load is between 5 hours to 7.5 hours in an let us say 10 hours operation, your load is between 45 to 42%. So that means the difference is about 13%. That means you have 10 tons available, but your requirement for 50 to 75% of the time is anywhere between 45 to 50%. Now what happens, let us say if you have a 10-ton air conditioning system, what happens, your requirement here is either 5 tons or 7.5 tons. for 87% of the time. That means for about 8.5 hours or during 10 hours, your requirement is between 50 to 75% load. Now, in this case, what happens to your balance available 25%? Now, that is known as the excess load that is available with you. That means increased capacity. We also call it as higher capacity available when required. That means you have 25% or 50% of the load additionally available to you when required or when you have peak load. However, we are not considering the peak load because peak load is only for 1% of the time in 1 year. That means when we say your air conditioning system is 10 tons, your 10 tons requirement is only for 1% of the time in a year. That means in 365, let us say, for example, 270 days of your operation. So 1% of 270 days is 2.7 days, and 2.7 into, let us say, a 10 hours operation. That means 27 hours only is your 100% load is required in an office space or a commercial application. Now, this has been defined in ASTRAE guidelines everywhere on system design or application or the load in a building. And this pattern gives us a very clear picture on designing our system or selecting our system design when we are installing a VRF system. I hope this is very clear on where this additional load is coming from or where this excess load is there. There are two parts here. One is the additional load requirement and the other one is the additional load availability. So let us move on to the next slide. So what type of application? Generally it is used, let us say, for example, a 12 hours operation with a varied load. I've just taken an office space. Let us say you start at 9 o'clock, or let us say a typical showroom. It opens at 9 o'clock in the morning, shuts at 9 o'clock, or a restaurant which opens at 7 o'clock in the morning, shuts at 8 o'clock in the evening or 10 o'clock. So the more you operate, the more you save with a VRF system because you are having some diversity between the indoor capacity and outdoor capacity. Then educational institutions provided cooling to campuses and school buildings can be a challenge due to the varied room types. For example, one classroom could be 300 square feet, the other classroom could be a 600 square feet, or you may have a lab facility, or you may have a conference room, or you may have a seminar hall, something like that. So where you have more students sitting in. Then you have showrooms which operates on 12 hours per day. Hospitality hotels where your room temperature, like you have a 50-room hotel, all the rooms may not be occupied. You may have only 10 rooms occupied or 20 rooms occupied, or you may have all 50 rooms occupied. One person may require 20 degrees centigrade, one person may require 25 degrees centigrade. So room temperature adjustment is also important there. So you are widely used in hospitality industry, healthcare, patients' comfort, different room temperatures, different kind of patients can have different comfort levels. So let us look at an example here of how we are going to achieve part load in an office building. Now let us say, for example, this manager cabin may always be off. He may be traveling, he may not be using. Or let us look at a meeting room. The meeting room is always not used. So this is a typical compact office space where different type of indoor units can be used. You can have a longer piping. You can have outside air or fresh air to give good indoor air quality. So the part load or COP is the biggest advantage in this VRF or a VRV system. It is more suitable for office buildings. The indoor units in office manager room runs always, or it can be vice versa. But the usage in meeting room and storeroom are quite different. So that means the usage in these rooms are not constant. They could vary from place to place or from room to room, and whatever is your requirement could also be different in different areas of the conditioned space. So residences, for example, you have a living room, you have bedrooms, like you have home theaters, Your home theater may not be in use when your bedrooms are in use, or two of your bedrooms may be in use. Your living room and home theater may not be in use. So these are where you can use these kind of diversity between indoor and outdoor. Right. So how to select this diversity? Now, I explained to you, if you go back to the earlier slide, the minimum available diversity is about 25%. That means if you have a 10-ton air conditioning system, you have an indoor unit of 10 tons. Now, what should be the size of my outdoor unit? So the size of your outdoor unit, what we discussed, was anywhere for 50 to 75% of the time will be anywhere between 42% to 47%. That means 87% of the time you will have load variation between 50 to 75%. So I will take the highest one, that is 75%. I am not considering diversity of 50%. I am considering diversity of only 25% because I am taking the higher load there, that is 75%. So assuming that 75% of the time you have peak load, I am considering only the 25% of the time. Now I am going to give you an indoor unit which is going to deliver your required quantity of air. However, I will give you a 25% lesser outdoor capacity because, for example, you require 3000 CFM or 3000 CFM of air. I will give you an indoor unit which will give you 3000 CFM of air. I will give you an outdoor unit, 300 CFM per ton gives you 10 tons. I will give you only 7.5 tons outdoor unit. Now this is known as diversity between indoor and outdoor. Now the important point to note here is the outdoor unit. When you consider the diversity, you need to consider the derating based on your ambient condition. Please refer your manufacturer's brochure or manual very, very carefully here. Generally, any VRF system is generally designed at an ambient temperature of 35 degrees or 30 degrees. It says, when you say 10 HP, they would have mentioned there 10 HP at standard condition. Now, what is that standard condition? Or they would have mentioned 10 HP at 30 degrees centigrade ambient temperature. Now, if you are in a place where your ambient temperature is 40 degrees, you need to ask them to give the data before considering, because you cannot simply say when your ambient temperature is 45 degrees more, 40 degrees, that is 10 degrees more, you cannot consider the same amount of diversity because some deration happens because of this higher ambient temperature. Let me explain to you how this deration happens, because the time taken for the condenser, let us say you have a 3 square feet condenser area, the time taken for condensation to happen during 30 degrees ambient temperature and 40 degrees temperature is more, or the surface area of the condenser may not be sufficient. It may take a longer time to achieve the desired tonnage. So hence, if you have a variation in ambient load, that will affect in your condensation, and the deration is happening in the outdoor unit. So when you are considering the diversity, you need to consider the deration and then consider the diversity. Suppose, let us say, for example, your deration is about 10%. That means if you have a 10-ton outdoor system and because of deration, it is going to give you only 9 tons, you can consider diversity for 9 tons and not 10 tons, keeping in mind 9 tons but not 10 tons. So that is how, that means if you are having an indoor unit of 7.5 tons, your outdoor can be only 9 tons. At this time, it is not 25%, it is only 15%. So the diversity, that is percentage, varies anywhere between ideally 20% to 30% or 10% to 30% or 35% based on application to application, manufacturer to manufacturer. Now, it is very, very, very important for us to understand this diversity, that is what is permissible, what is allowed, what can be designed. So generally, I would say any kind of application, unless it's a operation theater or XYZ kind of an application where you have constant load, you can safely consider a diversity of anywhere between 20 to 30%. And again, before you consider this diversity, consider these ambient conditions, consider this allowable diversity based on the manufacturer's manual, etc. This is how you can select, or this is how it is advised to select the diversity between indoor unit and outdoor unit. Then coming to this is what I was explaining to you about based on the conditions. Let us say, for example, look at the condition. What do they say here? At 35 degrees centigrade is what the catalog says. That means when I say if it is 10 ton air conditioning system at 35 degrees centigrade, it will give 10 tons. That means it can remove 1,20,000 BTU of heat. But at the same time, if it becomes 45 degrees, it may not remove 1,20,000 BTU of heat. It would derate itself. So deration depends on your pipelines, deration depends on your ambient temperature, deration depends on connected capacity between indoor unit and outdoor unit, and also the required conditions inside. So these are the factors which needs to be considered when you consider diversity. That means the duration has to be considered when you consider the diversity, which is very, very important. So that means the important factors, the number one is to analyze the inside condition, to analyze the outside condition, to analyze the quantity of air, to analyze the piping between indoor and outdoor, to analyze the temperature requirements of indoor capacities. So these are all the considerations that needs to be taken when you are arriving at diversity, or when you are considering diversity. A lot of people I have seen simply get into VRF system can give 50% diversity. No, okay, you give me 10 ton indoor unit, you give me 5 tons outdoor unit. No, I will manage, you don't worry. It doesn't work that way. There is a technology that happens, and when you consider technology wise, you have to consider it the right way. And this is some of the ways that you can calculate the right ways of diversity, and what needs to be considered, when needs to be considered, is what is very, very important. So the key benefits of the system when you are using diversity: consumes less power. I have explained to you by explaining the formula. P is equal to VI. Then provides high power when required, provides enhanced comfort, and very low starting current. Generally, most of the brands start with 1 ampere starting current. They are all soft starters. So that means there is no surge on your DG, or you don't need a higher power. So these are the key benefits while considering diversity. Then, so a VRF system, again, it's got an intelligent control. You can have BMS hooked to it. That means you can have individual room, individual temperature conditions, which is displayed here. You can have a set temperature of 25 degrees, 26 degrees, or 24 degrees. Each room can have a different type of temperature rating. So all this will be controlled by something called as a pulse modulating valve. Now there are a lot of controls, like I said. The PID was one. The second one is a pulse modulating valve, which all communicates between indoor and outdoor units, and your expansion valve in metering the flow of refrigerant. So then the types of indoor units, what you have a compact cassette, you have a two-way cassette, you have a one-way cassette, you have a slim duct, concealed ducted, floor mount, TFA, heat exchanger. I mean, you name it, you can have it. Then these are the capacities that are available. You need to look at it very, very carefully. So it is not only the tonnage that is also important. Now I have explained to you why the quantity of air is also important. So when you select the indoor, you need to select the right quantity of air also that is required, so that you have enhanced comfort. AHU connectivity, yes, you can do, but with limitation. You cannot consider any diversity with air handling unit, because your coil size is constant. That means your cooling coil size is constant. However, I will not say you will not have any power saving when you connect to an AHU. You will have power saving, but not because of not because of indoor conditions. You may have because of outdoor conditions, because when you design the system, you generally design for peak load. That is depending on peak load. Let us say I am based in Bangalore. The peak load for design is 37 degrees centigrade. So my outdoor is designed for 37 degrees centigrade. During my evenings time or early in the mornings, when I switch on the VRF system, the ambient conditions may not be 40 degrees or 37 degrees. So that will give us some amount of power saving. That means the compressor will run at a lower speed. However, your indoor needs to get a constant refrigerant supply based on your coil design. That is why we generally say that you cannot consider any diversity with a air handling unit. And you also need to have something called as an kit, AHU kit, convertible kit, which has got this electronic expansion valve to connect to your AHU. So I have explained to you in detail what is the peak load and what is the quantity of air. That is, you need to select the dehumidified CFM versus the tonnage, and you need to select the indoor unit based on the higher CFM, which will give you an enhanced comfort. Please note, if you do not consider the dehumidified CFM, you will be in real big problem, because the temperature inside the room when you carry a thermometer may show 20 degrees. However, you may not be comfortable inside because there is no movement of air. And if there is no movement of air, you are not comfortable inside a room. So these are the various capacities of outdoor unit. Generally, these side discharge units have single compressor, and the top discharge units have multiple compressors. Again, brand specific. Whatever I'm talking about, compressors, technology, speed, temperature, everything is brand specific. I'm repeating again, please read operation manual or your owner's manual before selecting the equipment. Each manufacturer, each brand has got its own limitations, its own advantages, its own disadvantages. So outdoor units selection, peak load, you can select the outdoor unit or you can select the diversity based on the application. So you have top discharge, you can combine 2 or 3 or 4, again brand specific. It depends on brand to brand, varies from brand to brand. Generally top discharge is on 8 HP or 6 HP onwards. You can also connect a treated fresh air unit to a VRF condensing unit. However, again, when you are connecting a fresh air or through a treated fresh air, again, you cannot consider any diversity here. It has to be considered as 100%. You can couple it with indoor units. Let us say in 10 tons, you can have 6 tons of indoor units, like say cassette or high wall, where you can consider diversity. But if you are having a treated fresh air unit for your fan coil unit, then you cannot consider any diversity for that particular unit. So fresh air is required today as per indoor air to maintain a good indoor air quality or a good indoor environment quality. You need to have a lot of air changes. So it is important for you to have outdoor air or fresh air coming in. So with this, I come to the end of my first presentation. So I would like to take any questions if we have. Probably we can take a break here and go back to, I will stop sharing my screen. We can go back to the panel's screen here. And if we have any questions, we can take some questions on this diversity part before I start my next presentation.
Thank you, Mr. Madhukar. We have some questions. So I'll just go one by one. So the first question is the question is, what is the difference between power HP and cooling capacity HP?
Power HP is generally considered as 1 kilowatt is equal to 946 watts, whereas cooling is considered as 3400 watts is considered as 1 ton, or it is considered as 1.25 HP. or 1 HP is equal to 0.8 tons. So there are two different things. Power for in electrical is related to the motor horsepower. Here it is considered to cooling horsepower.
Okay, the next question is, in VRF system, which compressor is better, twin rotary or S cooliter?
Sir, again, I don't make any comments here. It is for you to analyze. If you go to a scroll compressor manufacturer, he will say scroll compressor is better. If it is like you going to a doctor, two different doctors, and asking about the doctor, which medicine can I take? Can I take paracetamol or can I take crocin? Both are same. It all depends on what you want to use, what application. There are some advantages in both. There are some disadvantages in both. You have to analyze for yourself as to which is better.
Definitely, sir. So we will not go into those controversial questions.
So, we will answer controversial questions in a safe way. Don't worry.
Same, yeah. So next question is, but in case of VRF cassette, is it possible to get a 4-tier cassette with 2000 CFM?
Again, brand specific, sir. Please refer manufacturer specification. When you open a catalog of any brand, the catalog will say what is the tonnage it can deliver. The catalog will say what is the CFM it will deliver also.
Right.
Please refer.
Right. The next question is, annual operating time arrived based on 24/7 or operation or 12 into 5 operation?
Sir, you can arrive at your own operation level. Say the formula is given to you and it is left to you to calculate on whether you want 24/7 or 24/5 or 12/5. So the formulas are given based, see, generally ASHRAE has some guidelines and ASHRAE follows some guidelines. So you can make your own power analysis. See, I would always recommend you make your own analysis rather than depending on somebody, because you are the expert and you know, like for example, I cannot decide like how many parathas you can eat. So it is left to you to decide that how many parathas, how hungry you are, how many parathas you want. Or let us say, for example, my next meal that is available is only at 8 o'clock in the evening. Between 12 noon and 8 evening, I don't get anything. Then I need to decide for myself whether I need to pack my stomach with another half or extra paratha because I need to withstand for that much longer time. So this power consumption, operation, and diversity is all interlinked between each one, and it is always advisable for us to make our own analysis rather than going by books or records.
Definitely, sir. So I'll go to the next question. This is related to a cost comparison on maintenance and service. Since it's a technical seminar, would you like to go into this? Well, I would not suggest.
What is it? What is it?
The question is it true the maintenance and service of VRF system is costlier compared to a chiller?
That again depends on, okay, I would technically, I'm answering this question.
Yeah.
That again depends on the type. If you have a primary pump, secondary pump, BMS with VAV, everything, please make your own comparison again. Chiller is available from 35,000 rupees per ton to 1 lakh per ton also. The chiller design can vary.
Right. Next question is,
similarly even in VRF.
Yeah. Next question is, what ADP we need to consider for selection of VRF indoor units?
Again, brand specific, sir. Some brands offer you 52 Fahrenheit, some brands offer you 54 Fahrenheit.
Yeah.
And it also depends on your design conditions. You need to manipulate your design condition based on the ADP of the coil of the manufacturer. Now, if I am going to design at 50 degree ADP, if I make a heat load estimate, and if I am not going to get a cooling coil which will not give me 50 degree ADP, then I am in trouble.
Right. So my next question is from another party asked is, if all VRF indoor units consider constant load applications like also UPS or server room, whether diversity can be considered or not?
I have answered this question in my presentation itself.
Correct.
Because of the ambient conditions, yes, you will. No, you cannot consider any diversity, but you will have power saving.
Right. Next question is, VRF system, can the intelligent monitor, can it be connected with centralized BMS system?
Again, brand specific, sir. Either you have Modbus protocol, BACnet, whatever. Again,
Okay.
brand specific, refer manual.
Right. And there's one more question. I think the person who has wrote the question could not complete the question. Please explain once more why for TFA and AHU diversity factor can't be considered.
Sir, for example, if you look at treated fresh air, your A is always constant. When you say 3000 CFM, your 3000 CFM is constant, and your coil load is based on, let us say, if it is 3000 CFM, your tonnage load considered 400 CFM per ton is designed for say 7.5 tons. So your coil load is constant. So you need to have a 7.5 ton VRF outdoor unit by default. However, that is what I said, you will save some power consumption. Energy saving is, however, there because of variation in ambient condition. That is why you cannot consider, because your coil load is constant.
Right, sir. So that completes our question answer session for the first period. And you can now, if you want to take a break, we can take a break for 2 minutes because we have been speaking for continuously 1.5 hours. Otherwise, we
No
can
problem,
straight
sir.
away, otherwise we can straight away go to the second part, sir.
Let me just take a minute's break and then probably.
Definitely, definitely. Have some water, I'm sure.
One second.
Yes, sir, please.
Okay, I will close this.
That time I'll just ask the participants, those who have questions, I request them to please write a complete question so that it's easier for me to ask and the speaker to answer. So that's a request to everybody. Take some bit of a time and complete the question. Okay. Right. So it is visible, Mr. Madhukar.
Okay,
You can please go
can you
ahead.
see the screen now?
Yeah, types of indoor units is possible. I'm seeing it.
Yeah. Okay. Right. So let's move on straight. Now that we have understood about the basic, so let me not spend too much time on explaining what a VRF system again, because generally, if we are talking about good installation practice, generally I start from what is a VRF system and then go on. Since I have explained in detail about what is a VRF unit, so I will straight away start with the installation process, that is the types of indoor units what we have. And again, the disclaimer holds good here also. It is again brand specific. However, are not displayed in the slide here since I have displayed it in the beginning itself. Again, disclaimer holds good. And it is all the more important that we refer the brand specific manual here in this case, because it plays a very, very important role. I think I should have it in the end of the slide again. Let me just see. However, I am telling you, please refer manual for specific installation instructions. So what are the various types of indoor unit? You have high wall type, you have floor or ceiling mounting. Now, the difference between the previous floor or this is, this type of indoor unit generally needs boxing. So you can have a boxing with a small canvas connection. You can have a grill available to you. So that is the difference between this floor mount and ceiling mount and the previous. Now this is a finished product with nice finish, whereas this is an unfinished product which needs to be completed aesthetically. So then we have something called as a slim pack, which is called the tower model. Then you have one-way cassette, you have two-way cassette, you have four-way cassette, you have slim duct, you have medium static ducted, you have high static ducted. Then you can have AHU connected, but again with limitation. These again, you can have fresh air intake. The slide I had already shown in my previous presentation. Now the flexibility between indoor and outdoor, we have already discussed about this in length. We have discussed about the quantity, the design part of it between dehumidified CFM and tonnage of refrigeration, the various capacities of outdoor unit. Then how to select an outdoor unit between combined load and peak load. I think now we are masters in these slides. I will just skip these slides now. Now coming to this, the most important part. What is the quantity of piping which we can do? Now, can you see this? 1000 meters. 1000 meters is 1 kilometer. Now, does it mean that I am going to keep my indoor unit here, dig a trench for 1 kilometer on the floor and take my pipe for one outdoor unit there? No. Please note, when we talk of piping, it is the total piping length. That means, let us say, for example, if you have 50 indoor units, if you have 30 outdoor units, or if you have 10 outdoor units with 100 indoor units, the total piping length can maximum be about 1000 meters. So that is what is need to be understood importantly in terms of the length of the piping. Now, for example, I will ask you one simple question. A lot of people will say that when you go to a villa or an apartment to design a VRF system, you will be in the ground floor. They will ask you to install a 6 HP or a 10 HP outdoor unit on the 7th floor terrace. Is it possible or not? Please ask a question to yourself. This again has to be referred to the owner's manual or the manufacturer's manual or specification as to what is the maximum permissible pipe limit for that 6 HP outdoor unit and what is the number of indoor units which can be connected to that 6 HP. So for everything there is a limitation, for everything there is an enhancement. Now we need to understand, before designing anything, we need to understand what is the limitation or what is the maximum which I can go, that is the diversity which I can have between this. So it is very, very important for us not to go by, because I have shown 100 meters piping can be done. It does not mean that 100 meters piping, there will be some small asterisk somewhere in this corner here. And at the end of your specification, it will say terms and conditions apply. So if you have to consider that 100 meters piping, you need to know what the terms and conditions are. So you need to read the terms and conditions first and then decide what is the length of the piping. It does not mean that just because my manual says 100 meters, I am going to have 100 meters. So the connectivity between number of outdoor units, the number of indoor units, the piping lengths, etc. is brand specific, and whatever has been mentioned here is the availability of the availability, or I would say possibility. There is a possibility that you can have 1000 meter piping above 34 HP with the combination of multiple of outdoor units with the capacities, but the maximum equivalent distance between outdoor unit and the farthest indoor unit is 235 meters. That means the maximum piping what you can take between indoor unit and the outdoor unit is 235 meters. Now look at the difference between these two statements. Here the total piping length is 1000 meters. Here the maximum piping between indoor to outdoor is 235 meters. Hope this length of the piping is clear. Again, I am repeating, please go by brand specific, please go by the catalog of the manufacturer when it comes to piping and indoor units. So the maximum height is again 90 meters. Now this is what I meant. Now wherever you see this, you have to read what is this. Now this will say under what conditions, under what term, under what this thing. I will just draw a round there for everybody's better understanding. I will just draw one round here. Can you please, sorry. Just give me a minute. Can you see this? Now, this asterisk is very, very important for us to understand as to what that asterisk is before I actually conclude that yes, I can do 90 meters. No, I have to understand what this asterisk is first, why this asterisk has been given. So I need to understand this first and then decide what I can do. So it is generally 40 meters between indoor units, so which takes about 11-story building calculated at 3.5 meters. See, all this again, whenever you decide about piping length, etc., you have to assess the design condition or the building very, very, very clearly, understand the horizontal length of the piping, understand the vertical riser of the piping, how much horizontal length am I taking, how much vertical length am I taking, what is the total piping length, what is the capacity of my indoor unit, what is the capacity of my outdoor unit. All this has to be considered even before you start installation, because once the indoor unit and the outdoor unit is delivered at the site, you cannot simply go blindly, because generally every manufacturer will have his own piping software, and the piping software will also tell you what is the maximum length of piping you can do, what is the size of the piping, what you need to use, what is the type of Y joints you need to use. All that is generally again brand specific, and each and every manufacturer has got his own software for piping design. You need to refer that piping design software and get the drawing of the piping design and then start the installation work. So what is the total length is 1000 meters, height between FCUs is 40 meters, farthest pipe from first branch is again 90 meters. Now look at this, again there's an asterisk. So you need to understand what these aspects are. So height between condensing unit and fan coil unit, outdoor unit above is 90 meters, outdoor unit below is 40 meters, farthest equivalent length is 235 meters. So flexibility in piping design is a major factor for the evaluation of a VRF solution. Now, again, before you do anything, you need to ascertain that what is the route at which I am going to take my pipe, how am I going to cover my pipe, etc., etc. All this has to be designed even before you start the work. So you have flexibility of piping, you have something called as a header or a line branch. There are two types of joints that you require. One is a Y joint or the other one is a header joint. So this is known as a header joint. So if you have more number of piping or more number of outdoor units or indoor units, you can use a header joint. Then distributing of piping between these indoor units, you can use Y joint. You can use a combination of both, or you can simply have a header to header connection. You can have a header to Y joint connection, and this is known as header to header connection. This is known as header branching to line connection with a Y joint. So these are the two types of connections which you generally need or you use while installing a VRF system. So joints, generally known as the Y joints, advantages tends to use lesser piping, tends to have the difference between a Y joint and a branch joint is this is just one bracing, whereas if you go back to the header joint here, you have 4 bracing. So the more the bracing, the more the chances of leak. So hence it is desirable for you to have a Y joint as much as possible rather than a header joint. Of course, if it is inevitable, then you have no other option but to use a header joint. So this is a header joint. When you have 4 pipings, disadvantages tends to increase the pipe length. That means you will need more piping. You have more bracing to be done, and more bracing means more options of leak. So it is always important for us to decide what type of joints we need to use. So again, you can have a central remote controller which can be connected to any type of indoor system, where it gives you sitting at one place, you can monitor the various types of indoor units and the temperatures, etc. So there's a Modbus touchscreen. Connectivity can also have. Now let us move on to the most important part. A 410A refrigerant. What are the various tools that you require? Now selection of refrigerant piping material. Earlier there were some brands which were using 407C, but now I don't see any brand using 407C. Most of them have common refrigerant 410A. So what is a 410A refrigerant? Let us understand now what are the tools that are required. Then selection of refrigerant piping material, precautions that we take while doing refrigerant piping, outdoor unit installation, brazing work, and finally leak test. So these are some of the important practices or the good practices that we will understand how to do. So what is 410A? What are the precautions? Now 410A is a high pressure refrigerant. It generally takes 1.6 times that of R22. That means the operating pressures are 1.6 times more than R22. So it's a mixed refrigerant. It's a combination of two refrigerants in equal proportion. It is 50% of R32 and 50% of R125. So the type of lubricating oil that you need to use is an ester oil. It absorbs moisture easily. Never mix with mineral oil. Do not use the same oil that you use for R22 refrigerant. You have to use ester-based oil. So then you need to use specific tools while working on 410A refrigerant. So what are the specific tools that you need to use? You can use something known as a clutch type flaring tool, because generally when you use a normal flaring tool, you tend to crack the pipe, or the pipe loses its strength when you flare. So it is advisable to use a clutch type flaring tool. Once the desired amount of flare is achieved, it is something like a ratchet. It doesn't continue to flare further. So that is known as a clutch type flaring tool. So it is important for you to use a clutch type flaring tool. Again, a specified tool for R410A. Tube bender can be same as R22. Pipe cutter can be same as R22. Now you need to use a torque wrench. A torque wrench is the wrench that decides the amount of torque that you need to give while tightening a flaring nut, or by tightening your unions, etc. So it is advisable to use a torque wrench rather than your screw spanner, because if you use a screw spanner, you will not know what is the desired amount of tightness that you need to do. So you can damage the copper pipe or the flare. I have seen a lot of people using nose pliers for flaring. Never use nose pliers. Please use flaring tools only. Then use the torque, and the torque will again be specified in the owner's manual or the installation manual, that what is the torque you need to apply when you are tightening a suction flare nut, or when you are tightening a liquid flare nut. What is the amount of torque which you need to give for torque wrench is specified in the manual. Again, gauge manifold, it has to be a high pressure gauge manifold specific for R410A refrigerant. Charging hose, again R410A dedicated. Charging cylinder, dedicated R410A. Then leak detector, again R410A dedicated. Now these are very, 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 very important things which you need to do, which you need to keep in mind when you are installing a VRF system. So vacuum pump, the same can be used, but you have to make sure that the oil to be changed as and when required, or as and when desired. So refrigerant charge, same as a weighing machine. You need to use a weighing machine. It can be same as R22. Brazing, yes, it can be same. However, the process for brazing is different. I will explain to you in further slides. Now, refrigerant reclaim, that means you can recover refrigerant from the system, and the recovery of the refrigerant, you have to have a separate condensing unit. You have to have a separate recovery unit dedicated for R410A, and not the same what used in R22. So these are some of the joints that we use. We use something known as T-joint. we use something known as a Y joint, that is also known as the branch joint. Then we have something known as the header joint. The header joints can be very on 4 branches or 8 branches. These are all some of the fittings that are specifically used for VRF systems. Do not use this for R22 applications. Do not use local made joints. There are a lot of people, say for example, if you are buying from company, your joint starts anywhere between 2,000 rupees to 3,000 rupees, whereas some joints are available at 300 rupees, 400 rupees. Never buy those joints because the joints tend to crack over a period of time. Now, this is the difference between a local joint and a good joint. A local joint will develop something like this, and you will start getting leaks here. So do not use local joints. Then the most important part is we never clean the pipes or the fittings before we use. Please note, R410A refrigerant is very sensitive to moisture and non-condensable gas. It is very important for you to follow the guidelines that is mentioned, because any small amount of moisture will result in contamination of gas, and the quantity of gas is huge here when compared to another type of system. So when you are doing a VRF system, you need to take a lot of precautions, you need to take a lot of care, and never take any shortcuts, never bypass any practice. So you need to have a dry pipe. There should not be any moisture. Make sure that you clean the pipes. You can use a cloth and a wrong rod to just push the cloth inside and take it out from the other side. Make sure that there are no dirt inside, and make sure that the refrigerant does not leak. That means use proven brazing techniques. 3 precautions to take with refrigerant piping: it has to be dry, clean, and it has to be leak proof. So the recommended type of brazing: when you are joining 2 pipes, always use a swedging tool. Do not use a nose plier, and the bigger diameter pipe has to come down. The smaller diameter pipe has to be from the top, because if you do not do this, what happens is when you are brazing around here, the metal sits here and it leaks. Now, if you are doing this kind of brazing here, the metal keeps falling out here and the metal doesn't stick. Hence, your brazing is not going to be uniform. So this is not the right way to do the brazing of pipes. This is the right way for brazing of pipes. Horizontally, again, you need to fill the material here. You can fill the material here when you do the brazing, and this is very important for us to understand. And again, when we are doing Y joints or etc., the position of the Y joints is also very important when you are trying to braze. Then this, I don't think even today, even though it is the most important part to follow while brazing, nobody does this. This process is known as bleed off brazing. It is most important type, or the most important part that you need to follow, procedure you need to follow while installing a VRF system. You need to follow this procedure called as bleed off brazing. Now, if you have to do this bleed off brazing, you need to have a 2-stage regulator. Always use a 2-stage regulator. Now, never ever compromise on safety. Safety is utmost important at site. If you are working on heights, always use a safety belt. Wearing safety belt is not only important, you have to anchor the safety belt. I have seen a lot of people wearing a safety belt but not anchoring themselves. It doesn't solve the purpose. So wear a helmet. Do not bypass any safety procedure. Always use a 2-stage regulator. Now, the advantage with 2-stage regulator is you can regulate the required amount of nitrogen which is required for you to braze. Please note, you have, when you connect this to a brazing joint while you are doing brazing, you connect the hose inside and you allow about 2 to 3 psi of nitrogen from here. So when you are heating this pipe, this nitrogen keeps blowing inside, and any amount of carbon deposit that can get inside here gets blown off by the flowing of this nitrogen. So this process is known as bleed off brazing. The process of allowing 2 to 3 psi or 4 psi of nitrogen into the pipe you are brazing is known as bleed off brazing. This is very, very, very important for you, and you need to follow bleed off brazing, because as I had explained to you in my earlier presentation, your expansion valve has got 2000 steps. If look at the minute movement that your expansion valve does. Now, if you do not do this bleed off brazing, in the next slides, there's a picture which shows the carbon deposit. That carbon deposit can go and sit inside that expansion valve. So please do not compromise on this. Please do bleed off brazing only when you are doing VRF piping or VRF brazing. So this is what the oxidation that happens. Now, if you look at this, this is your black soot inside. Now, this black powder can go and block your expansion valve. So this is without nitrogen, and this is with nitrogen. Look at this. There is not even one single iota of carbon deposit here inside this pipe, because you have used nitrogen blow here. If you do not use nitrogen blow, this is how your carbon deposit gets collected inside the copper pipe. Now, so what is the leak test procedure that you need to follow? The first procedure that you need to follow is step 1. You have to check at 3 megapascals or 3 kg per centimeter square. So 3 kg per centimeter square is about 75 psi. So at least for 3 minutes for large leaks. Then step 2, you need to use say 15 kgs. 15 kgs is about 225 psi. Again, at least for 3 minutes for large leaks. Then step 3, 38 kgs, that is about 500 psi, or the design pressure. Now again, this, please note this, it can be even 35, it can be 30. Again, you have to refer manufacturer's manual. Now, the minimum gas leak, the pressure testing, what you need to do is for 24 hours. Now, here also, never ever compromise. The customer will put always pressure on you. He will say, tomorrow I have got inauguration of my store. Tomorrow I have got housewarming ceremony. Tomorrow I have got opening of my hotel. Please tell the customer well in advance that you need 3 days time to commission the system. And when you keep on stressing this to him, sir, I will need 3 days time. Sir, I will need 3 days time for commissioning. Please do not put pressure on me. It is a technical procedure that I need to follow. Please note, if you develop a leak in a VRF system, it is very, very, very Herculean task for you to identify leak. The more precaution you take, the more good installation practices you follow, the safer you are, the more you save money. Now, spending more time here will help you reduce lesser money and enhanced service to the customer, enhanced benefits to the customer, and less trouble to you as installation person or service personnel. So never ever compromise on these things. Minimum pressure 450 psi to 550 psi, again based on manufacturer to manufacturer. Again, minimum 24 hours. I would rather say do it for 48 hours and not 24 hours. So the pressure will change approximately. Now, this is again very, very important. You need to note down the time and the ambient temperature. Let us say, for example, you have charged 450 psi today, and your ambient temperature is, let us say, 19 degrees centigrade. Because it is in the evening, your ambient temperature is 19 degrees, you have charged, let us say, 400 psi or 450 psi. Next day morning, you may go to the site at 12 o'clock and check for the nitrogen pressure. So the nitrogen pressure would have gained some pressure. Please note, temperature and pressure are directly proportional. That means if the temperature increases, the pressure also increases. So if your ambient temperature has increased to what, say from 19 degrees in the evening, it has increased to, let us say, 35 degrees at next day 12 o'clock. Please note the pressure change will approximately be 0.1 kg per centimeter square for 1 degree. That means if you have charged, the difference in temperature, what we are talking now, is about 15 plus 1, 16. So 16 into 0.1 is 1.6 kg. That means 1.6 into 15 is about 20 psi. So that means if you have charged 450 psi the previous day, it can increase to 470 psi. Again, you have to note the ambient temperature. When you charge nitrogen, you should note down the ambient temperature and the pressure what you charge. Otherwise, say vice versa. Let me come back to the second scenario here. You are charging nitrogen at, let us say, 7 o'clock or 8 o'clock in the morning, when your ambient temperature is, let us say, 30 degrees. And in the evening, when your ambient temperature is 19 degrees, there could be a drop in pressure. How much can you drop? So every drop of 1 degree centigrade, 0.1 kg. So in the afternoon, when you check if there is a drop in 3 psi or 4 psi, it does not mean that there is a leak in the system. That is why we say pressure testing should be done at least for 24 hours so that you can measure at the same ambient temperature or the same temperature with which you have given nitrogen pressure. So this is something which is very, very important, and the procedure what you need to follow while doing a leak testing. Do not compromise on this process. Do not compromise on this procedure. Come what may come, go what may go. Otherwise, you will lose very heavy money. Then record time and temperature, compare start test data and adjust the temperature difference. Again, I am telling, when you charge nitrogen today at 4 p.m., please go back tomorrow at 4 p.m. and check what is the pressure. That is the right way of doing it. Or the right, note down the temperature and check when the ambient temperature is there at whatever time you started, ideally to check the right temperature or the pressure again. Then these are some of the minute places where you can develop gas leaks. Please note, it is very, very, very difficult for you to check the minute leaks. So please take proper care while brazing. Do a proper pressure test. Minute leaks take longer time to detect. So what is your flow of installation work? First, you can install the outdoor unit. Then you come to the piping installation. Then the insulation, piping insulation. Then indoor unit installation, drain piping installation, and control wiring. This is generally the flow of work that you can. I'm not telling you should. I'm telling you can follow. Then power wiring, pressure testing, addition charge of refrigerant, address setting, and commissioning, test operation. So these are some of the procedures that you need to follow. So the arrangement of outdoor unit should be header unit, follower unit 1, 2, 3, or it can be vice versa. Then this arrangement has to be made when there is multiple outdoor units. So the header unit, follower unit, and follower unit 3. Now, in case of any problem in one of the units, now this can become the header unit. This can be bypassed. Again, brand specific. You may have to check with the brand whether you can do that. Then, so this is the correct way of doing the T-joint. That means when you have header unit and follower unit, you cannot do it this way. You need to bring individually every unit and then take one header pipe outside. This is the correct way of doing the header joint and this thing. You need to have one liquid line and one suction line, and you cannot have multiple joint like this, one like this, and one vertically you cannot have. Your T-joints should be horizontal only. Your T-joints cannot be vertical. Okay, please note this. Some of us make this mistake, and then the address itself will not take, because this will have a rapid flow of refrigerant because of the gravity flow. So this is not the right way of doing it. However, this is the right way of doing it. Then do not use local T-joints. Again, I am telling, It could result in cracking. It could result in damage of your pipe and loss of money. Then when you are installing an outdoor unit, these are some of the mistakes what we generally make. Do not have these kind of errors when you do the installation. Do it right the first time, do it right the correct way. Then again, using rubber pads, we are used to saving money for our company and just the support. Now, generally, usually the client gives the support. It is advisable to have these kind of support for full length of the VRF outdoor base rather than keeping 4 bricks in 4 corners and giving rubber pads only to that. Now, this will result in some amount of vibration. So it is always advisable to have a solid base for the full length of the base of the VRF unit and then have the full rubber pads rather than having it in pieces. Then this is another way of doing it. Again, this is the good practice. If you are mounting it on the floor, then again keep this rubber pad completely for the units and do not give only for here. Now this is not a good practice. Now use proper foundation bolts, use proper anchor fasteners. Now you have to be very, very careful if you are drilling on a ceiling. Make sure that you use waterproof sealant later, otherwise it may start leaking at the floor below if you are doing it on a ceiling. Now this is a very bad practice. You have to do it in a proper way. Use a bigger washer, cover the hole completely. Now vibration pads not along the entire length. Do not try to save any money for your owners or anybody. Do not try to save any money. Have these rubber pads completely installed. Then tightening the flare nut. Now look at this. It shows very clearly what should be the torque that you need to apply when tightening. Now you have to follow specific this thing. You have to use proper torque wrench only. For example, it says if you are having a 6.4 diameter copper pipe, the torque that you need to give is 1.4 to 1.8 kg force per meter. So that is the pressure what you need to get. And always use 2 spanners. You can use 2 torque wrenches to give, or 1 torque wrench can be used to tighten the flare nut, and 1 normal spanner can be used just as a lever to your union. Never hold cutting plier. Never use pipe wrench. Never use grip pliers. I know a lot of people use this practice at the site because you may not have the spanner, but that is not the right way. Get the right spanner, get the right tools to work so that your work becomes easy and you do a good professional job. So the material used is you will have to use a proper recommended material, nitrile rubber or a foam material with heat insulating more than 120 degrees or more. Again, refer manufacturer specification for this based on the thickness. The thickness also varies based on whether it is hard drawn or whether it is soft drawn, whether it is 13 mm or whether it is 19 mm or whether it is 20 mm or whether it is 24 mm. So please check all this thickness of the insulation, thickness properly, and make sure that you do not, some people have the habit of splitting this insulation and then inserting it. Do not do that. Before you braze, please do the insulation. Now the slit should be upper side so that the slit should be here. If the slit is down here, then you will not be able to tighten it properly. So these are all some of the important small things which will make mistakes at this site. Always use a rubber pad when you are having a bracket. It is shown in future slides also. So this is some of the insulation specification that has been given. So make sure that you use the same kind of specification when you choose the right amount of insulation. Do not compromise on all these things. Then, so this is a bad installation practice. Now look at this. The pipe has to be completely covered. Now it is only half covered. It is not fully covered. So make sure that you don't leave anything open like this. You have to follow the right procedure for insulation and covering the insulation properly. Then make sure that the drain slope is given. Now generally, where does this problem happen? Now I will just draw one simple figure here. Now you are the person, you are standing here. I am just making a diagrammatic representation of a person standing here. Now you are installing, you have to install a indoor unit. You have to install an indoor unit here. I'm drawing an indoor unit. Now look at the height at which you are standing. Now when you put a drilling machine or a drill gun, look at the way you are doing this drilling here. That means this is wrong. What then? What is this? Is a wrong practice. What the right practice then? The right practice is, what you need to do is you should be at a higher level. That means you should be, if you want to install a high wall here, now the way you need to do the hole is you need to be standing at a higher level, somewhere like this. You should be standing, and then you should be drilling the hole in this manner. This is the right procedure. Please note, this is the right procedure and this is the wrong procedure. You should always be at a higher level when you are drilling the hole and not at a lower level or at the same level. Now, if you do this, what will happen is the water will come back into the unit here. This will result in water leak. So maintain the slope. It is very, very, very important for you to maintain the slope. If you do not maintain the slope, it will result in water leak. You will never be able to solve this problem. Then you need to have a proper drain support at every 1.5 to 2 meters so that there is no buckling of drain pipe. If there is any buckling of drain pipe, then what happens is your water will get stagnant there and there's a possibility that it would come back. So you cannot have multiple bends in a drain pipe. You need to have only the required way and the right way. You please do not use these hoses. We have a bad practice of using this gardening hose. Please do not use those type of hoses. Use rigid pipes only. Give a proper U-trap so that there is no airlock. If you do not give a U-trap, then there's a possibility that there is an airlock here and the water will start coming back into the unit, which will result in water leak. So these are all certain important things that you need to follow, giving a proper U-trap at the piping wherever that is required, not using the zigzag hoses, use the rigid PVC pipes. So for a 4-way cassette, generally what is the height that it can take? People say that you have got a drain pump, please have a drain pump. Please note, there is a limitation. This height, what you can take is, again, there is a limitation. Again, it is brand specific. Please refer to the owner's manual in terms of size, what you can take. So drain overflow problem may occur otherwise. Then power supply, always again rating, you have to check on the rating. 3-phase, you will need L1, L2, L3, that are R, Y, B. Please make sure you get neutral also. You need to have a 4-core wire, or you can have a 3-core wire with a neutral separate. So the wire connection has to be a star connection. Frequency and voltage 380 to 450 volts plus or minus 10%. Then power to the outdoor unit. This is not the right way to connect the power. What is the right way is, this is the right way to connect the unit. Get independent parallel power connections to each outdoor unit and connect them separately, or have an isolation or power panel at the outdoor space and then distribute it individually in this way. Do not follow this type of procedure to save money or to save the electrical cabling. It will not work. So the right way is, this is the right way to do, and make sure that each outdoor unit is earthed separately. Do not have a common, or even if you want to have a common earthing, provide a strip here and then take a common, and that strip make sure that is the earthing capacity that is required is to the desired level. Then again follow the power supply. When you are giving the power supply should come to the header unit, then to the follower unit, and not vice versa. Make sure that all these are very, very important when you make do the wiring. You have to make sure that you follow the right procedure that is given. Otherwise, the system will not take the address and it could result in problem. So use various models will have various capacities. These are some of the sizes that you need to use. Again, brand specific, refer owner's manual or operation manual. So you give proper earthing to every indoor unit. Do not compromise. Don't have a common earthing for all the units. Make sure that each indoor unit is individually connected to a common header earthing. Then this must be independent from the outdoor. Do not use the same outdoor supply that you use for indoor. The indoor power connection has to be separate. The outdoor power connection has to be separate. Now, this is a direct connection, no MCB here. Now, this do not have this practice. Generally, it is advisable to have one isolation box on the terrace and bring the main power supply to the isolation box, and from that isolation box bring wires to connect to your outdoor unit. This is very, very important for us to understand. Then make sure that there is no evaporation on the indoor unit. This could result in short circuit. Now this condensation water on this pad here can fall on your PCB, and this can result in a short circuit. Make sure that once you install, make sure that there is no condensation on the indoor unit. These are all some important checks which we generally don't do, but we have to do. These are known as good practices. Make sure that there is no condensation here. Then the electrical outdoor to indoor, indoor to indoor, again it has to be, these are known as communication cables. The cables have to be taken in the right way, which is specified in the manufacturer's manual. Now, this is again, do not have any cable joints. This will result in the cables getting heated. This will result in more complaints. So do not have any joints. Use one single strand cable if possible, or if you have to have a multiple joint, there are ways and means to join this copper pipe. Follow those procedures only. Maybe if you can use a small junction box here, have a junction there, have a connector there, and join the two wires to a connector rather than putting insulation. So leak test method, like I said, the first procedure is give about 450 psi, wait for some time, and make sure that the pressure doesn't drop. However, if you have suspect any leak, let us say for example for 24 hours you have tested the leak, there is a drop of 5 psi or 10 psi. If you have any doubt, allow it for another 24 hours. If there is a further drop of 5 psi, that means that there is 100% leak. So make sure that you check all those kind of leaks. Now, this service valve here, you will generally have a gland, and when you open and close the stem, or when you open and close the service valve of the VRF system, make sure that there is no leak in these glands. Generally, we don't check leak here. Now, this is a gray area, and this leak is very, very common because the outdoor unit, you do not know how many months back it would have got manufactured, it would have got stored. The neoprene material inside would have lost its property. So if all that has happened, then there could be a leak here. So make sure when you do the pressure testing, you check for leaks in your valve stems and your glands here. Wherever there's a valve, you will have a gland. Make sure that you do pressure testing there, or you do soap spotter and bubble testing there at the glands. Then be sure to apply pressure to the gas line, liquid line, and any other connection. Now, if you have still further doubts, There are two ways of giving nitrogen pressure. One is you can give to copper pipe separately. You can isolate the indoor unit separately and give pressure for the indoor unit separately. However, outdoor unit will have refrigerant pressure, but make sure when you open the outdoor valve, if it is showing 0 psi, please do nitrogen test. It cannot be 0 psi because all condensing units comes with pre-charged refrigerant. All these condensing unit comes with pre-charged refrigerant, and if you do not get, if your gauge does not show any pressure when you open the valve, that means there is no gas in your condensing unit. The condensing unit could have leaked. So make sure, if that is the scenario, you give nitrogen pressure to the condensing unit also and test for leaks. Then again, this I have explained to you earlier also, minimum 450 psi, or you can go up to even 500, 550 psi on the high side. On the low side, limit yourself to 250 or 300 or 400 psi, not beyond that. Then the pressure change will change based on your ambient temperature, which we have explained earlier also. So the procedure for vacuuming is use always a double stage vacuum pump. Never use a small vacuum pump. Understand the piping length. Understand the capacity of the vacuum pump required. And the vacuum you need to achieve is 500 microns. Please note this. It is not for 2 hours or not for 3 hours, not for 4 hours or not for 5 hours. Generally, you have to achieve for 500 microns is what you need to achieve. If you do not achieve 5 microns, it means that there is leak somewhere. If you are vacuuming for say 1 day or 1.5 days and you are still not able to achieve 500 microns, maybe you are stuck at 2000 microns or 3000 microns or 4000 microns, it means that there is a leak somewhere. So make sure that if you achieve 500 microns, and if that 500 microns is holding for about 2 hours or 3 hours, it means that there is no leak and you have a perfect leak-proof system. So be sure that you vacuum to both suction line and the liquid line, and make sure that the entire system is evacuated, your entire piping is evacuated to 500 microns. Be sure to use a vacuum pump with a non-return valve or a solenoid valve, because since you need to evacuate for a long time, VRF system takes about 7 to 8 hours for evacuation to achieve 500 microns. And if there is a power failure in between, then there is a possibility that oil from your compressor can come back to the vacuum pump. So in order to avoid this, or vice versa, vacuum pump oil can go back to your outdoor unit. That means there's a mixture of two different properties of oils, which is not advisable. So it is always advisable to have a non-return valve or a vacuum pump with a solenoid valve, so that this can be, the minute the power goes, the solenoid valve will shut itself, so that there is no oil coming back from either vacuum pump or to the outdoor unit, or outdoor unit to the vacuum pump. Use the desired level of vacuum pump. Generally, I would recommend a 500 liters vacuum pump, which is, suppose for example, if you are using a 40 liters or a 50 liters, it may take a longer time. The more the liters and more the dual stage. Use dual stage so that you achieve vacuum faster. So vacuuming procedure, vacuuming value to reach 1 megapascal, close the valve for gas manifold, stop the vacuum pump, leave as it is for 1 hour. If there is no change in vacuum, it is good. But if there is change in vacuum, then that means there is a leak somewhere. Go back again to nitrogen pressure testing and make sure that you find the leak and follow the same procedure. So minute leaks, I had shown this picture earlier also. So any minute leaks, make sure you find these minute leaks. The points are, the loopholes are where you have done brazing, your Y joints, your header joints, your valve stems. Your valve stem is the most common leak joint that you get when you open the valve stem or when you operate the valve stem. So make sure that you check your leak at the valve step. Then additional refrigerant calculation is again given by the software, the actual liquid pipe length plus the running meter, the additional pipe, the length of the pipe, what you have, and then considering the tonnage of the system, the refrigerant charge is mentioned. Again, these are all brand specific. More the length of the copper piping, you may have to charge some additional gas. What is the quantity of additional gas is given by the software, or there's a table which is given by the manufacturer. It suggests what is the quantity of refrigerant to be charged. With this, I come to the end of this presentation also, so we can take some questions. The most important part in an installation, good installation practice, is bleed off brazing. Always follow the procedure of bleed off brazing. Never allow carbon content to deposit. And the other important thing is the positioning of the Y joint and the positioning of the joints and the pipes. Then the third thing is achieving the vacuum, then leaving it under nitrogen, doing pressure testing for about minimum 24 hours. The more you do, the better. And these are all some of the important things which you need to follow. Please do not compromise on these things. With this, we are open to take any questions if you have.
Thank you, Mr. Madhukar. It was really exhaustive and it was really detailed, and I could realize what all real life challenges people face after having a wrong installation, or a shabby, I would say, if I can use that word, installation. It is always better to take some time and get the things done right in the first time itself. So before I go into questions, I'll just request one of the participant, Mr. Amol Kulkarni, to please write your question again. Okay, now you got it. Okay, fine. I got the question of Mr. Amol. So I'll come to the questions one by one. The first question is, sir, there's a question called how can we control some room which require heating and some room which require cooling? In this case, how will the outdoor unit will work?
Very good question. There is something called as if you are having only one piping, one header pipe, that is one set of piping, you cannot achieve, either you can achieve all heating or all cooling. If you want to achieve one cooling and one heating, then you have to use something called as a two-header pipe system. So if you use a two-header pipe system, that means, let us say, for example, you have one header pipe connecting 10 indoor units. That 10 indoor units can work in cooling cycle, and the other two header pipe which is running is connected to another 5 indoor units. So those 5 indoor units can be connected to heating cycle or vice versa. It cannot have that you have one or you independent condensing units with independent piping you will be able to achieve. Let us say, for example, you have 8 outdoor units. You can couple 4 outdoor units with one header piping and 4 outdoor units with another header piping. This is known as a two-pipe system, and you can still have both these pipes connecting to the same outdoor unit. You can have one condensing unit working on heating cycle, one condensing unit working on cooling cycle.
Right, sir. So I think there's a question related to the same thing. That somebody asked is, what is the difference between 2 pipes and 3 pipe system in VRF system?
I have answered this.
Yeah, exactly. So just for the participants' satisfaction, I actually asked this question. Okay, there's one more question is saying that can we leave the system under vacuumized condition overnight?
You can.
Okay. Next question is what is 1 second, sir. This question is I'm not able to understand. I'll come back to the question later. What is the pressure limit for the entire system like ODU, IDU, or piping? The pressure limit.
So generally for ODU it is maximum pressure is every unit will give you a test pressure. Generally every manufacturer will give you a test pressure for condensing unit, test pressure for piping, test pressure for this thing. Otherwise, usually it is the highest pressure that is encountered in a VRF system is about the discharge pressure, which is around 400 to 450 psi. At least you should do to 450 psi on your high side. On the low side, yes, maybe you can compromise a little bit. But always any piping, if you do pressure testing for 400 psi, you're on the safer side.
Okay, now the question is, I'll just rephrase the question, which one more question has come is, if there is a condensation inside the cassette on the electrical panel, what could be the wrong installation practice followed there? I mean, क्या गलती हो गई थी?
Yeah. Generally, once you come below the cooling coil, there will be an insulation which would have been applied on the below the cooling coil on the face of the indoor unit. Now, if that has worn out or if the insulation has lost its property, then condensation can happen. So all you need to do is just remove that old insulation, and then you have to remove the entire paste, scrape it with some emery paper or something, apply some good resin, and then do this reinstallation of this nitrile rubber that is used. So that will prevent from this thing. Or if there are any air gaps, also there is a possibility that we could have this condensation happening.
Right, sir, because there's one more question of similar nature, because you already answered this. The person has asked is, what is the cause of dew condensation in indoor units? So you have already answered similar to that, right? Hello?
Yeah.
Yeah. Okay, and there are no more questions, sir. People have really enjoyed. I can get a lot of good feedbacks on the chat box. I think it was a very apt topic, which a lot of people have taken it really to heart, and something which pains is available in the real life market. So thank you, Mr. Madhukar. It was a pleasure having you.
Welcome, sir. Welcome. Once again, I'm stressing, please follow safety guidelines. Do not compromise on safety guidelines. It is important to follow safety.
Okay, before I wind up, there are two things more. Can I have your email ID, sir?
It's Madhukar at climatics.co.in.
Okay.
MADHUKAR. It is there in my presentation. It was okay. MADHUKAR.
Yeah, I noted it down.
I will put it on the chat box. I've
done it, sir. I've done it. There's one more question which just came out. Is there a possibility to change split ACs into VRF system?
No.
Okay.
You can discard the old split AC and install a new VRF system.
Right. So you have my email ID, Mr. Madhukar. You could share the.
I have put it on the chat box.
Yeah.
I have put my mail ID in the chat box.
Okay. My email ID is also, I have put it in the chat box. So you can just share the presentation to me, and we can maybe distribute to the participants.
One second. I am not able to see your email ID.
1 second, sir. 1 second. I'll type it again. 1 second. Yeah. Is it visible now? somujitbanerjee@gmail.com.
Yeah.
Okay. So you can share the presentation, and so that I can do so with the participants. And thank you, sir, for a wonderful thing. And for 2.5 hours of continuous talking, I can understand how tough it has been, and getting all these things ready with the backup and all the presentation slides. So it's a pleasure having you, sir. I'll officially meet up and take your guidance in future. Thank you.
Welcome, sir.